These engineers at NASA's Jet Propulsion Laboratory in Pasadena, California, are assembling the satellite for an exciting new Earth science mission set to launch in November 2014. The SMAP, or Soil Moisture Active Passive Satellite, is an environmental research satellite equipped with state-of-the-art instruments for taking soil moisture and freeze-thaw measurements all over the globe. The satellite combines two key instruments, an active radar and a passive radiometer, which can provide high-resolution, accurate measurements at a frequency and scale never before possible.
Right now, what people are using is a few sparse measurements of soil moisture at a relatively small number of areas over the Earth, and then they apply those measurements to models that infer what the soil moisture is on a global level. What SMAP will do is we'll replace that with a much more accurate direct measurement of soil moisture over the Earth.
In addition to their scientific value, these data will be immensely valuable for a number of applications, from weather forecasting to disease control. And the scientists behind SMAP have been working with end users throughout the mission to ensure that the data will be suited towards their needs and easily assimilated into their operations.
SMAP has a really rich heritage. It goes back over 15 years. It started off as Hydros and developed into the SMAP mission. And so it built up this really great community of people that have an interest in using soil moisture data. And so that community is known as the Applications Working Group. And from that community, we grew what's known to be as the early adopters.
We identified 25 early adopters, and it's continuing. I say 25, but it's continuing to grow. We'll probably have 30 or maybe 40 by the time we launch. And these early adopters are using their own resources to prepare for the launch because they understand that soil moisture and freeze-thaw information is going to be important for their decision making.
The early adopter program was meant to capture the most dynamic and the most focused and motivated of all the institutions we've engaged with through the applications programs, to get them to use satellite data as early as possible.
What we asked them to do is also provide us some feedback. What was their rate of success in whatever they were forecasting, predicting, or monitoring before and after the availability of SMAP data? And we want to see that difference in order to bring it back and do the data product generation even better.
This video tells the stories of the SMAP early adopters. This diverse group of businesses, government agencies, and organizations represent the end users for SMAP data, and their collaboration on the SMAP mission ensures the integration of these data into operations that affect our day-to-day lives.
I'm Michael Eck. I'm the Land Hydrology Team Leader at the Environmental Modeling Center. We're part of NCEP, the National Centers for Environmental Prediction, and they have a number of centers of which EMC is part. There's also the Weather Prediction Center, the Hurricane Center, Severe Storm Center, and we provide national guidance for the rest of the Weather Service and NOAA with environmental prediction. Weather models definitely need a very good initial condition, because if you don't have a good initial condition, you're starting from the wrong place. So SMAP and other remote sensing products and other data sets that we use that are on the ground, for example, help us to better characterize or better describe what that initial condition of the surface is. So is it frozen or not? Exactly what is the soil moisture? We worry about other things like, is there vegetation? How green is it? There's a number of conditions of the surface that we need to know, and soil moisture is probably one of the most important. Essentially, as our models, our weather and climate models are going to higher resolution, we want to be able to match that resolution with the input data that we get from the remote sensing.
AER is an atmospheric and environmental research company. We do research related to everything to do with the Earth system and monitoring the Earth system. So oceanography, land surface processes, the atmosphere, clouds, and even the space environment. We're interested in SMAP for a number of reasons. The foremost for me is its capabilities for providing information for models of terrestrial ecosystems that analyze methane emission and its contribution to greenhouse gases. The other reason we're interested in SMAP data is for mapping of large flood events. SMAP is going to have a capability to resolve more details in flood events in a more timely manner. This is important for disaster management, for understanding where aid might be needed and where resources can best be utilized. What's most exciting about SMAP is that it's happening. I mean, we have been talking about in the soil moisture community, in the hydrological community, a sensor like this for my entire career and probably before that, so back to the mid-'80s. So this will finally give us insight into a problem that up till now we've only been able to get at from less capable means.
The National Drought Mitigation Center is a unique center in that we are the only group in the United States that focuses completely on drought monitoring, drought early warning, drought planning. We have a variable group of scientists and staff that work on this mission continually, and it has evolved over the years. The group has started about 20 years ago now, and we've definitely evolved over time into the mission that we focus on reducing drought risk across the country.
Soil moisture is really a critical component into understanding drought and where it's developing, how severe it is. Traditionally, soil moisture information has been acquired through ground-based measurements or probes in the soil, which are few and far between. So we're interested in SMAP to give us more detailed information on soil moisture variations across large areas and really fill in the gaps between where these sensors are on the ground to give us a more detailed spatial view of how things are changing in the soil over time.
As we get these data at a higher resolution, covering the entire country, we're going to do our jobs better. When you see the drought monitor map coming out each week, we're going to have more confidence in some of the inputs that we're looking at, especially with regards to soil moisture, are going to be of a higher level and of a greater quality and more utility than anything we've had up to this point.
The Cold Regions Research and Engineering Lab is one of 7 labs that belongs to the Engineering Research and Development Center. It is a collection of labs owned by the U.S. Army Corps of Engineers.
We became involved with SMAP because we have always been interested in ways to remotely get soil moisture information in areas that we're not allowed to go.
SMAP is one of the first new sensors that provides us a strong leap into the future to be able to more accurately and more precisely measure soil moisture. And that soil moisture is real critical for military mission planners when you're talking about soil strength, you're talking about mobility, or you're talking about just water security. The ability to measure that soil moisture from space is very important for military planners.
The Army always has to get people and things from one place to the next. And if they have multiple routes to choose from, the soil strength based on the soil moisture, which is provided by SNAP, will say this route is better because it's stronger soil, so you can get more things over in a given amount of time.
It's fascinating being on a much larger team and working with these applications to show how critical satellite data is to our weather analysis and our climate system, our climate prediction systems that we all work with.
At Storm Center, we work with different agencies and organizations that monitor the environment, climate change, and natural disasters and hazards. And what we do is we help integrate products from Earth observation into decision making. We have developed products that are currently being used by emergency management and by U.S. agencies to deliver impact-based decision support services. And we expect to be able to integrate SMAP data within this stream of data products that are being delivered to these emergency managers and other agencies. A lot of the data that's currently available is either at a very low resolution or is not readily available when our decision makers need it. And we are expecting SMAP to be able to fill in those gaps, to actually make that data available when it's necessary to take those decisions. SMAP data will be one more tool in the toolbox that decision makers and emergency managers have across the nation. It will enable them to take better decisions when it comes to figuring out what impacts soil moisture will have on their operations.
My name is Kyle McDonald. I'm a professor of Earth and Atmospheric Science at the City College of New York. I work with the NOAA CREST Institute at City College and also the Environmental Crossroads Initiative. The New York City Department of Environmental Protection is interested in using the information content from the SMAP data products to inform them with new information on the integrity of their watershed for supplying the New York City potable water. As SMAP early adopters, we are working with them to assist them to be ready to integrate SMAP information into their assessment schemes for looking at the quality and amount of water that's available to the City of New York. It's a very new and exciting application for remote sensing science because we'll be able to use this new data set that will be routinely available from space orbit as a new information source to hopefully get an improved understanding of the issues that face providing water supply to growing populations.
NAS is a data collection arm of USDA, so we are National Agriculture Statistics Service. We collect agriculture-related statistical data and provide it to the general public.
We're looking at the SMAP mission to help us define when the growing season begins, looking at the freeze-fall cycles, using the rapid repeat cycles that the satellite will provide us and give us, giving us more objective and scientific readings than we can currently get from our ground-based enumerators, which number about 4,000, and potentially this could be a real big cost-saving measure for our organization. We're very excited about the improved objectivity and scientific basis that this SMAP mission will provide our organization. It will improve our agricultural statistics monitoring capabilities and give us better methods and means of delivering our message or our scientific information to the public.
The IRI is a research institute hosted by Columbia University that seeks to help society understand, anticipate, and manage the impacts of climate variability, particularly in the developing world. Efforts to help rural populations cope with the impacts of things like drought and floods requires the ability to anticipate those impacts.
We are trying to test the utility of SMAP soil moisture products to improve the prediction of crop yields. If we have better soil moisture data, then we can correct better our models. And hence, the expectation is you will have a better estimate of your yield.
SMAP provides a great deal of promise for improving the accuracy and potentially the lead time of model-based forecasts of food crop production for food security, early warning, and management. Our hope is that this will allow food security response organizations to anticipate and act on the threat of food insecurity driven by things like drought much earlier in a way that will protect not only the lives but the livelihoods of rural populations that are vulnerable to the impacts of drought and floods.
The SMAP early adopters featured in this video represent only a portion of the full early adopter program, but these organizations dedicated to pushing the limits of technology represent a major step forward in the widespread implementation of satellite data and will continue to be an integral part of future NASA missions for many years to come.
Early adopters are going to play a significant role in our NASA missions. They have already shown that they provide significant feedback to NASA, and I think that they get a lot of good value out of participating as early adopters. Each mission is unique, and so how the early adopter programs will be formed and the types of early adopters will always be different. But I think early adopters are really something that's going to stay in the NASA missions.